Well, hey everybody, it's your friendly neighborhood math teacher again, and today what we're bringing to you is the Pythagorean Theorem, right? The thing that we know and love, and it couldn't be any better. It's just awesome, and oh my goodness, it's on steroids. Okay, so the Pythagorean Theorem is pretty cool the way that it is. A squared plus b squared is c squared. Very simple, but today we're going to take this up just another notch, and we're going to include those things that we have done recently called radicals. Okay, so we're going to see how those play into this idea of the Pythagorean theorem. So let's focus up here, and we will be able to have a good time with our steroidal Pythagorean theorem. All right, Pythagorean, that's awesome. Okay, so this is your standard Pythagorean theorem, right? It's a right triangles only, of course. We know this, that's standard. Right triangles only, and we have two legs and the hypotenuse. Okay, so the two legs are right here. Always, it doesn't matter what you call them. Obviously, we use A and B as kind of the standard. You can call them or give them a variable, whatever you want, but they got to be the legs right over here, the ones that come off of the 90-degree angle. And then our hypotenuse is always going to be the side that is opposite of the right angle. And we're going to label that one C very typically. Okay, so let's just dive into a problem here. Explain it a little bit more here. A squared plus b squared is c squared. That's standard there. You guys know this. So let's take a look here. If we've got this question right here, we have a right triangle. No, I didn't put in there that there is the little right symbol, right angle symbol. But that's only because we're talking about right triangles right now. But don't forget that this only works for right triangles. And typically you're going to want to make sure that it is a right angle, meaning the question needs to state, hey, is this right triangle correct or something like that. So we just need to know that it is a right triangle. Most of the questions are going to denote that with this little symbol here. So obviously we've got a missing side. Okay, C is our missing side here, and it is the hypotenuse. And so what we're going to do is we're just going to take the information that we have, and we're going to plug it into our equation. This one right over here, the Pythagorean theorem equation. So our two legs are 2 and 3, and remember that our legs are going to be the A and B over here. So those ones are going to be on one side. You could think of this as the legs squared and added together equal the hypotenuse squared. That's a way to think of it. So we're going to input this into the equation like here. So 2 like here. 2 goes right here, 3 goes right here. So 2 squared plus 3 squared is going to equal c squared. Let's solve it out here and let's see what we can do with this. Okay, 2 squared is 4, 3 squared is 9. We're going to add those two things together and we get 13 is going to be equal to c squared. Notice that this just kind of continues down here. Okay, we haven't done anything with it yet. If we want to solve this, we need to get what c is equal to. We don't want to know what c squared is. We want to know what c is. So in order to undo this, we are going to use the square root symbol. Okay, going to do the radicals here. And so the square root of 13 is equal to the square root of c squared. Well, the square root of c squared, that's simple. That becomes c. And so then what do we do over here? Obviously, I wrote down that it was just the square root of 13. Why is it that you think I did the square root of 13 as opposed to actually writing out what the answer is? Okay, take a second and guess, or not really guess, but think about what we've talked about before. Remember, I've talked to you about this concept of being as accurate as possible, right? We always want to try and be as accurate as possible. And so the question is, what is more accurate? Is it more accurate to say the square root of 13, or is it more accurate to try and write out what the square root of 13 is? So if I were to find the square root of 13, then we're looking at a decimal that would be 3.60, type correctly here, 60555, and then 1, and it would continue on forever and ever and ever. Okay, so tell me, think about this class, which one's more accurate? Is it going to be the one that says 13, square root of 13, which represents a number, or is it going to be this right over here? Okay, this we would typically round, right? Is there any possible way for us to write this full number here? No, there's not. We've talked about this before. So the more accurate answer is going to be this, because I can plug this into a calculator. I can even work with this in another equation if I need to. However, this number here, it's impossible for me to write its most accurate version and work with it unless it looks like this. So we're not going to worry about this over here, okay? we're going to write it as the square root. Okay, so let's just, okay. So be thinking about that. If it comes down to where when you find the square root of a number here, if it ends up being an irrational number meaning, it's never ending, it doesn't repeat, so it's just all these random numbers, then you would want to write it as a square root, still as the radical. Okay, so let's take a look at another question here. First off, let's look at the difference between these two. Notice in the first one we had 3 and 2 as the legs, and the hypotenuse was c. Obviously, there's some differences here, small difference. We have one leg, and we have the hypotenuse, and we want to find the other leg. So, just a little bit different. But here's the thing. Plug it into the equation, just like you normally would, and then we'll see how it all works. So, a squared, okay, that's our first leg. 2 squared goes right there, and then our hypotenuse squared is over on the other side by itself. Remember, the hypotenuse is going to be the one that's by itself on the side of the equation. So if we plug this in, we can start solving it out. If you wanted to move some things over, you could, but I'm going to solve it out first, and then I'm going to move things. 2 squared is 4, 5 squared is 25, and I'm going to subtract 4 from both sides to get that moved over properly, pardon me there. And so we've got a squared equals 21. Find the square root. Okay, so the square root of a squared is a, and then the square root of 21. Well, is it a rational number or is it an irrational number? Well, this one happens to be an irrational number. Okay, the square root of 21 is not nice, so it would be 0.45 or 4.5825756949558 blah 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 blah, and it would go on forever. So we have our most accurate answer sitting right here as the square root of 21. Okay, we do know what we can do within these square roots, right? Is we can simplify these square roots. Possibly, can this one be simplified? Well, no, this one would be 3 and 7. Those are both prime numbers. You can't simplify that anymore. But if you do get to one that you can do it, please do. Okay, and we'll see some examples in the homework there with that. Okay, so again, it's kind of basic here. We're not talking brain busters here. Okay, go with the exact answer, please. Don't go with the approximate answer. Okay, do another one. 3, 4, C. Maybe somebody's thinking something already right now. If you are, good on ya. Let's plug it into the equation. Okay, we've got our 2 legs right here, 3 and 4, and then the hypotenuse is there. So the hypotenuse is all by itself on the right side. Solve, 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 solve. We get 3 squared is 9, 4 squared is 16. Add them together to get 25. I know that I'm going quick. You guys have a pause button. Okay, don't forget to use that pause button. So we have that. And the square root of 25 equals the square root of c squared. Well, that gives us 5. So we don't need to worry about writing it as a radical because it works out. Right? The square root of 5 works out. Okay, so let's go again here. Oh, this is where it gets crazy. Because the last ones, if we go back here, indulge me, if we go back here, these ones weren't too bad. This is standard. This is like what you're going to see standard-wise, okay? You guys can solve this out very easily. Now, what we're getting into is, oh my goodness, we got these square roots in here. We got the radical symbol. So what are we going to do? Oh, man. Well, let's just write it into the equation. Don't freak yourself out and think that it's going to be that much harder because it's got a radical in it. Why don't you try and put it into the equation first? So this is what it looks like. A squared plus root of 8 squared equals root of 11 squared. Well, what happens right here if we do the root of 8 squared or the root of 11 squared? Hopefully what you're writing down is that it just cancels it out. Okay, so we get 8 equals 11. So a squared plus 8 equals 11. We just got to subtract 8 from both sides and we get 3. So then what do we have to do here? Well, we have a squared, and so if we want to know what a equals, then we square root it. Okay, so we get the square root of 3. So it wasn't too terrible. Okay, in fact, it's about the exact same amount of work. So, let's not get too crazy with it. Again, please try and do the exact answer. Okay, I would much rather you put down the exact answer as opposed to just allowing your calculator to try and solve it for you. Okay, so question 5 here is slightly different. This one, pardon me. What we want to do here, obviously you can see if these are the lengths of the sides of a triangle, okay, there's not a missing length. It says one side is 3, another side is 4, and another side is 5. It doesn't tell us that one of the sides is C or X or something like that. It gives us all 3 sides, so what do we do with it? Well, What we want to do is figure out if it is a right triangle. Can we have a right triangle with these sides? Okay, now we need to be specific because a right triangle has very specific properties. In a right triangle, this right here, I'm going back, this must be true. This has to be true. A squared plus b squared must equal c squared. If it doesn't, it's not going to be a right triangle. It's impossible. It'll be a different triangle. It won't be a right triangle. So what we're doing with this one here, if I can get back to it, is we are trying to determine if it is a right triangle. Okay, so let's plug it into our equation. Okay, let's plug these numbers in to our Pythagorean theorem. Well, the question is, where do they go? We have a squared, b squared, and c squared. Which ones are which? Okay, take a second and think about that. Two of them are going to be legs, and another one is going to be the hypotenuse. What do we know is true about the hypotenuse? Think about that for a second. The hypotenuse is always going to be the largest side, the longest side. So which of these numbers is going to be the hypotenuse? Well, it's got to be the 5. So when we plug it into our Pythagorean theorem, it has to be right over there, okay? So 3 squared plus 4 squared is 5 squared. If we solve that out, 9 plus 16 equals 25, 25 equals 25, we would say true. So what did we determine here? We have determined that if we were to write a right triangle with these side lengths here, it would be a right triangle, okay? It would be accurate, okay? So that's the task that you were trying to do. So let's kick it up a notch. Again, this is the steroidal Pythagorean theorems. So, by the way, this is called a Pythagorean triple. If they're whole numbers and it forms a right triangle, then it's a Pythagorean triple. Okay, whole numbers. All right, so let's look at this one. 3, 7, and 9. Let's see if this one works. So we're going to plug it into our Pythagorean theorem. Which one goes in the hypotenuse slot? The longest one, so that should be 9. So therefore it's 3 squared plus 7 squared is 9 squared, okay? 9 plus 49, does that equal 81? No, it does not. So 58 does not equal 81, so therefore false. You could not draw a right triangle with these 3 side lengths. Okay, not going to happen. It would not be a right triangle. It could be a triangle, but it will not be a right triangle. Okay, now let's take it up a notch. Square root of 5, 7, and 3 root 6. Oh gosh, which one is going to be the longest side? That is going to be the kicker. You need to determine that. So use your calculator. There's nothing wrong with using your calculator. Plug in 3 root 6 and see what you get. 3 times the root of 6. See what happens. Well, what you will find is that this one is going to be the longest side. Okay? I'm going to pause you right here and I want you to think for a second. In each of these 3 examples, this number was the longest side. The third number in each of the questions, right? The one at the very right side of it. Please do not make the mistake of thinking that the third number, the one on the right side, is always going to be the hypotenuse, because I could have said 453 or 354 or 534, whatever. I could have done any different combination here. It doesn't really matter. I'm not telling you leg, hypotenuse. I am telling you the side lengths. It doesn't matter what order they're in. You need to determine which one is going to be the hypotenuse. So don't forget to test that every time, okay? So with that one, finding out that it's going to be the longest side, then what we're going to do is just put the other 2 over there and solve it out. Okay, so 5 plus 49 equals 9 times 6. Well, 54 does equal 54, so therefore true. We could draw a right triangle with a side length of root 5, a side length of 7, and a hypotenuse of 3 root 6. It would work. Okay, that actually is it. It doesn't get any harder than that, to be honest with you. We are going to limit ourselves to this right here. It's going to be what we call this down here, examples 5, 6, and 7, is called the Converse Pythagorean Theorem. Converse, kind of like the shoes. Converse of the Pythagorean Theorem. Theorem. And what this means is essentially we're testing it. Okay, this is kind of like a testing thing. Does it work? okay? At least for the purposes that we're doing right now. We're testing to see if it is a right triangle, okay? So those are the two different tasks. You're either going to find a missing side length like we did up here, okay, and what it might be, and then also we're going to be using the converse of the Pythagorean theorem to see if it is true or not, okay? Now up here, I want to point something out here. When we find the root of 3, if you're thinking appropriately as a math student, you're saying, okay, what about the positive and negative numbers, right? I know that last lesson we were talking about only the principal square root, which is only the positive. In this one here, we need to square root the number 3, and whenever we need to operate with the square root, whenever we are performing the operation of square root, then we need to be thinking about, is it positive or negative? Well, we're only going to use the positive, but why? Is it just because of the principal square root? Or is it because we are talking about the side lengths in a triangle? And I have pointed out to you before that in the side lengths, if it is length, distance, it can never be a negative number. So we do not have to worry about the negative number of these, okay? It is always going to be a positive because we were talking about the side lengths. I cannot have a length that is negative, okay? So be thinking about that. Please do your best. And don't forget, email me with any questions. Hop on the video chat. I will be available for any of that. Have a wonderful day.